Hi, we're here a long distance range TV antenna and FM. He has a motor that moves the antenna and has incorporated a booster signal, which is very useful. This is from China for long distance, like a range from the TV station, and you can upon the antenna and cap the signal. I here modify this antenna for work for 12 volts because we have solar energy, and this antenna only works with 127 volts. So I incorporate one cable for the motor and the signal, the antenna normal cable. Okay, so watch this. Now here I have this modification. This was the control box from the antenna, and okay, and this is a power supply, 12 volts power supply that would be in a panel, solar panel. Okay, here is the on switch, about 1 ampere fuse and one reverse dial to lock the dial. As one power regulator for 12 volts for the model, and the 12 volts for the motor, and 5 volts for the microprocessor. Okay, here we have a big 18 this, for microchip, and here we have from a remote control car H point bridge that I is used for like an inverter. The motor antenna work with 20 volts alternate current, and this converts the 12 volts to AC and drives into the cable. From here, this a diode bridge, and here, and moves the antenna. And this microprocessor from microchip, like the team, the stuff, they block me. They don't send me any more samples. Bullshit. Okay, like the thing that does this generate a square wave for this stuff, for the inverter. Because the time and precision and some stuff, I couldn't do it with a timer. It was so very difficult for me to make the inverter for the. Okay, and he has a MOSFET, ERF48N, optocopper. Okay, the remote control. I modify. I just element with 12 volts, and the 12 volts element the booster for antenna, and I pick up the signal from the controller, from the remote control, like this. And when I use the remote control, look what happened. I push, I start to move the antenna. Okay, could you see? Oh, okay. We cannot see it because a low light. Okay, so I pick up the signal, which the optocopper polarize the MOSFET, and the MOSFET energize the bridge and the microprocessor, and move the antenna. And I'm moving the antenna, and now it's working with 12 volts. Okay, I am moving the antenna. You see, you will improve the signal. Okay. You can ask why I did that. I do this. The stuff is like we have a solar panel, and with this stuff you will need to use an inverter, IC inverter, for pick up the TV stuff on the TV stuff. So I save money in the inverter, and this it could look like, but it's a very cheap. This is from a car. From a remote control car, RC. This is regulators, and all the stuff is from scratch, and I buy this and modify it, and I have a TV LED that, and now the stuff I will use for a solar panel with a battery, and in a range with is very far, like 150, 120 kilometers from the antenna. With this stuff, I trust that I can get the TV reception, and everything here and the TV work with 12 volts. So this is a modification, the antenna, rotating antenna with 12 volts. It's a very cool stuff, like that with a Chinese antenna I modify for my purpose. This is a very good antenna for the price of 200 pesos Mexican. It's like a 20 bucks. It's very cheap, and the antenna moves, and you can get this signal. So the regulator, the microchip, the chip, the microprocessor. I need a very precise timing here, pulse training. I don't know why, but because I don't use a transformer, I just use a direct couple. But the motor in the antenna is very special, because when it returns to the own way. So very okay. See you then, and we got this comment. Okay, see you then. Bye.